The last type of chemical bonds that we're going to look at are metallic bonds. And a metallic bond is a force of attraction between a positive metal ion and the valence electrons it shares with other ions of the metal. So these positive ions form a lattice-like structure. So a lattice-like structure is basically just a nice grid-like structure. So you'll notice in the picture, our positive ions are forming this nice fence-like structure, very orderly, and then the electrons are floating around in between those positive ions. So the ions are held together by bonds with the valence electrons around them. So there's an attraction between the positive and the negatives. This includes their own electrons and those of the other ions. These valence electrons are not held tight. They're actually moving freely. And so we refer to this as a sea of negative charges surrounding the positive ions. So these electrons are just floating around. They're not just staying here. They could be moving here to the left. They could go up. They could go down. They're just moving about in between those positive ions. So metallic bonds and their properties, they're good conductors of electricity because they have the free moving electrons. So remember, in order to conduct electricity, electrons have to be able to move. So anytime we have moving electrons, we have good conductors. Metals or items with metallic bonds can be shaped without breaking. And the two ways that they often get shaped are in ductile and malleable ways. So ductile is the ability to be shaped into wire, and malleable is the ability to be shaped into thin sheets, like aluminum foil. So the metallic lattice may resemble like a rigid crystal ion or an ionic crystal. However, it is much more flexible because it has those moving ions or those moving electrons. Those moving electrons allow for flexibility. They do not shatter like the ionic crystals because the ions of the metal can move within that sea of electrons without breaking. The ions can shift closer together or farther apart, and those electrons just fill in to prevent two positive charges from getting too close to one another. So those electrons will sneak in to form a barrier, which prevents them from shattering. So the last thing that happens with metals is the creation of alloys. Alloys are mixtures of a metal with one or more other elements. The other elements can be metals, nonmetals, or a combination of both. They form a solid solution, and so these are created by melting a metal and then dissolving the other elements in it. Then that liquid molten solution gets cooled and hardened, and then we have an alloy that we can use. So pure metals are often less useful than these mixtures. So for example, iron is not as strong as steel, which is an alloy, and it's a mixture of iron and small amounts of carbon. And steel is used to make skyscrapers, cargo ships, cars, trains, and to hold up bridges because it's so much stronger than iron. And steel also doesn't rust. So does not rust. So in terms of cargo ships, being around all that water is a good deal.